Hello everyone. Let's take a look at our next problem. Okay, so this says prove that the square root of 3 is irrational. A lot of people are familiar with the proof that the square root of 2 is irrational. Often one of the first things you ever see in any kind of class on introductions to proofs. I'm assuming that the exact same line of logic will work here, so let's just work through it all. So we're going to suppose that the square root of 3 is rational. This means the square root of 3 can be written as p divided by q, with p and q in integers with no common factors. But this means that 3 is equal to p squared divided by q squared. So 3q squared is equal to p squared. Now this means, the left-hand side is a multiple of 3. The right-hand side must also be a multiple of 3, which means that p itself must be a multiple of 3. For some value of k. But this means 3q squared is equal to 9k squared, and q squared is equal to 3k squared. But this then means that q is equal to 3 times m, for m an integer, and this is where we have our contradiction, because we assumed that p and q had no common factors, but here we've shown that p is a factor of 3 and q is a factor of 3. So the proof works out exactly the same way as it would for the square root of 2. We just have to identify that things are multiples of 3 rather than multiples of 2. Thanks for watching.